Artificial sources of radioactivity are part of everyday life. They are used, for example, as fuel in nuclear power plants, for diagnostics and radiotherapy in medicine, and last but not least, in industry. We do not live in an ideal world, and therefore various crisis situations can occur that threaten people's health. For example, a fire in a hospital's radiology department, an accident involving a vehicle transporting radionuclide sources, the loss or theft of a source, and so on. Radioactive material can also be misused, which is a very current topic given the present international situation. The danger lies in the fact that radiation is not visible. Is there any solution to minimize the risk? How, for instance, can a stolen radiation source be found?
In the RaDron project, we focus on locating sources of radioactive radiation using drones. We are currently at the test helipad within the premises of the State Institute for Nuclear, Chemical and Biological Protection. The aim of this experiment is to test that we can locate a stationary radiation source, as well as a mobile source.
If we do not know the level of risk, we do not want to expose people to danger. Therefore, we must use machines, such as drones, to map the situation. Speed is crucial. This means that ideally, the drone will determine the direction from which the radiation is coming and quickly find the source.
We are currently observing a demonstration of a swarm of drones equipped with a Compton camera trying to locate a radiation source. Placed in a briefcase. It is the highly dangerous cesium-137, and in our scenario, this radiation source was unlawfully stolen, and the briefcase was thrown out of a car.
How does it all actually work?
Our drones are equipped with a set of sensors. To accomplish the given task, we have a GPS signal receiver here, which allows the drone to fly autonomously within a designated area. Additionally, we have a very good 3D LiDAR. This is a scanner that enables the drone to avoid obstacles and map the area around it. And finally, we have a very important Compton camera, which allows the drone to see ionizing radiation and is capable of locating the source of the radiation.
What is a Compton camera?
The company Advacam develops ionizing radiation detectors that allow for the measurement of various information about incoming particles. Specifically, in this project, we use the Minipix Timepix 3 detector in Compton camera mode. This means that we use the Compton effect, which occurs in the sensor of the detector, to locate the source of the radiation, and we are able to calculate where the radiation is coming from, using appropriate algorithms, that is to say, where the source is located.
Source of radioactivity sounds risky.
Within the RaDron project, we provide sources of ionizing radiation and ensure testing spaces and conditions, as well as creating precise Monte Carlo simulations of the detectors used. The radionuclide sources we are using here today were brought in these transport containers, which are designed to protect us and our surroundings from the radiation emitted by these sources.
How was the search for the briefcase stolen radiation source? Can the software locate it?
On the map, I can see where our 3 drones are, which are searching for the emitter 2.5 meters above the ground, and then one that is flying 6.5 meters above the ground. That one will continuously scan the area. And as our drones approach the emitter, they gradually measure information from the Compton camera. These are the green cones, which indicate the set of possible directions to the radiation source. Here we see the hypothesis of the emitter's position, including the uncertainty. Those are the purple circles.
The moment the drones detect enough gamma radiation photons emanating from this source to reconstruct its position, they will head to that location.
Now these 3 drones are orbiting the emitter, continuously refining the position, and the drones have already found the emitter, and now they are refining the information about its position.
The drones quickly found the stolen source. Can the drones track a source that is moving?
While in the previous experiment we had a static source, in this experiment the source will be moving. So we place the source on a robotic dog. which will walk around the area with it. As in the previous scenario, the drones are tasked with locating the source again. This time, their task will be more challenging because the source will be moving the entire time when the source relocates. The algorithm should determine the new position and send the drones to this new position.
The drones are currently measuring approximately 2 Compton cones per second, which is enough information for them to track the emitter and refine its position.
And we can see that as the dog approaches us, the drones are also gradually getting closer to us and keeping pace with the dog.
A total of 36 experiments were conducted with different types of sources, such as cesium-137, cobalt-60, europium-152, with activities ranging from 88 to 500 megabecquerels. In all cases, the drones found the source within 1 to 2 minutes. The key to quickly finding the source is determining the direction from which the radiation is coming. This is a unique feature of the entire developed system.
In the project, we focused on locating radiation sources using drones. But we are, of course, aware that drones have their limitations, and in addressing a real situation involving radiation threats, it will be necessary to use other robotic means, and very likely, a combination of them, for example, a combination of drones and some ground-based means. Compton cameras can also be integrated into other robotic devices. So here we actually have a demonstration of a robotic dog carrying 2 detectors, 2 Compton cameras. The integration is very similar, if not exactly the same. As in the case of the drone, the concept is that the dog would autonomously locate the source based on data from the Compton camera.
The autonomous system involving drones, special detectors, and control software was developed in collaboration with Advacam, the Faculty of Electrical Engineering at the Czech Technical University in Prague, and the Czech Metrology Institute. This system addresses potential crisis situations associated with improper or illegal handling of radiation sources.